Okay, we're going to take a look at the section 1-8 note packet and do the notes for distance formula and midpoint formula. So if you want, you can actually take a minute and turn off the video, or hit pause rather, and then answer those first 4 questions, finding those square roots. So hit pause now. I'm going to put the answers down, and then you can come back and check. Okay, so those are the answers. We'll talk about any that you might have questions on tomorrow in class. Hopefully you got those. Now, again, you can hit pause because we're going to evaluate some expressions. I'm going to put the answers here, and then you can come back and check them. Okay, now I think we should talk about 7 and 8 because some of you may have forgotten how to multiply two binomials. And these are both binomials. Remember, you've probably heard this before, FOIL. FOIL, first, outer, inner, last. So we're going to multiply the first two terms together. X times x gives me x squared. X times 1 gives me x. X times 2 gives me 2x. 2 times 1 gives me 2. Add like terms. Those will be the center terms. X squared plus 3x plus 2. Number 8. Remember that n minus 3 squared means n minus 3 times n minus 3. So you need to FOIL this as well. N times n is going to give me n squared. N times negative 3 gives me a minus 3. Minus 3 times n, again, gives me a minus 3. Minus 3 times minus 3 gives me a 9. Therefore, I have n squared minus 6n plus 9. So that's a review of a few algebra concepts that you had last year. So now, let's talk about an ordered pair. An ordered pair, remember, is a location in the coordinate plane and it's represented by an x value and a y value, and it both indicates distance and direction from the origin. And remember, the origin is 0, 0. The coordinate plane is actually the intersection of two number lines. We have the x-axis, which goes from minus infinity to plus infinity. And then we have the y-axis, which also goes from minus infinity to plus infinity. It's divided into 4 quadrants. So we have 4 quadrants. This is quadrant 1, 2, 3, and 4. So that's the coordinate plane. Should look familiar to everyone. When we're looking at, in this section, distance and midpoint, we're going to be using the coordinate plane. You're asked to find the distance between 2 points, so go ahead and graph those. Remember that the first ordered pair is x and the second in the ordered pair is y. So I'm going to go to -4, -1, and plot my point R. Then I'll go to 5, 5, and plot my point T. And I'm asked to find the length of that line. Now, I don't know how many of you remember the Pythagorean theorem. You should have seen that in middle school. A squared plus B squared equals C squared. We're going to look at how we can use the Pythagorean theorem and then look at how the Pythagorean theorem relates directly to the distance formula. If I go ahead and draw a right triangle here, just add those lines to make a right triangle. This horizontal distance would be A, the vertical distance would be B, and that diagonal RT would be C. So you can simply look at the length of A, which would be 9, the length of B, which in this case would be 6, and you could use the Pythagorean theorem, 9 squared plus 6 squared equals C squared, so 81 plus 36 equals C squared, so 107 equals C squared. Therefore, C is equal to the square root of 107. Now, if we think about this, and we want to get to the distance formula, this value of A is really taking this x coordinate, we're going to call it x1, and this x coordinate, we're going to call that x2, and actually just finding the absolute value. Remember, that's the distance, right? So if I'm looking at this Pythagorean theorem, A squared plus B squared equals C squared, A I can really represent by x, the absolute value of x1 minus x2. B then can be represented as this is y2 and this is x1, y1, or x2, excuse me, y2. And that's x2, this would be y1. So this would be y1. So we can look at that as the absolute value, so the length of this line between those two, y2 minus y1. So that's how we get the length of the line. We just look at those y values and subtract. Just look at those y values and subtract. This is y1. So then we can replace B with the absolute value of y1 minus y2, and that is equal to, and then actually those are squared in the Pythagorean theorem, so we'll square them, and that equals C squared. Now if you think about it, an absolute value makes a number positive. Squaring a number, multiplying a number, a negative number by a negative number, would make it positive. So do you need to have both of those written down, or does that seem a little redundant? And what happens is we don't need both of them. We can actually drop the absolute value signs and just have x1 minus x2 squared plus y1 minus y2 squared equals C squared. Now to find C, we then just take the square root of both sides. And so the square root of x1 minus x2 squared plus y1 minus y2 squared is c. And that is the distance formula. And we'll write it again. Okay, so we actually can derive the distance formula from the Pythagorean theorem. But if you couldn't remember the Pythagorean theorem and you had time to draw a coordinate plane, you could go ahead and draw that right triangle and use the Pythagorean theorem to find the distance between those 2 points. So the distance formula is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So right now, I'm going to ask you to take a minute and go ahead and do this example. I'm not going to do it on the video. We'll do it tomorrow in class. But I will help you think about it because we'll label T x1, comma, y1, and O x2, comma, y2. So just make those substitutions and solve that radical. And we'll go over that tomorrow in class. Next thing we're going to do is take a look at finding the coordinates of the midpoint of a line in the coordinate plane. So again, I have my point R, which is at -4, -1. And then I have my point T, which is at 5, 2. And I want to find the exact middle of this line. And again, if you wanted to, you could draw the triangle, and you could say, well, what point is halfway between these 2 points horizontally? So from -4 to 5, that's 9. So it would actually be about a half. And then if you look where it would be on the x-axis, you're just finding the midpoint of this line, the halfway point and the halfway point, and then you can find the midpoint. It's probably going to be a lot easier, and hopefully you remember the midpoint formula, where you simply take those values. So let's label these x1, comma, y1, x2, comma, y2. So the midpoint formula is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So you're taking a 1 x from each and then a y from each. So in our example, we have -4 plus 5 over 2, and then -1 plus 2 over 2. So the midpoint is at 1/2 and 1/2. And that's about what it looks like on our picture, 1/2, 1/2. And that's the midpoint formula. I'll write it here, and then again, oh, this isn't the same thing. X, I'm trying to hurry, so I shorten the video. x1 plus x2 over 2, y1 plus y2 over 2, and that's the midpoint formula. That's the midpoint formula, which you're going to use in a minute. A different type of midpoint problem that we have is when we are given an endpoint. So we have an endpoint at -3, -2. There's A. We're given that the midpoint is at 3, 4. And we have to find that other endpoint out here somewhere, B. And there are several different ways to do it. I'm going to demonstrate a few. You can choose the one you like, and then that can be the one that you go ahead and use. So between A and M, that's half of the line AB. So this is half of AB, segment AB. So I need to construct the other half. Again, I'm going to use that right triangle to do it. I'm going to go horizontally, 1, 2, 3, 4, 5, 6 units. And then I'm going to go vertically 6 units. So from this point M, I'm going to apply the same slope that I have here. So I'm going to go horizontally 6. And then I'm going to go vertically 6. And that would be where my point B is. And that is at 9, 10. So actually using the graph and constructing that right triangle is one way to find the other endpoint. I think an easier way, and a student asked me if this was okay a couple of years ago, and when I looked at it I thought, oh my, this is a much easier method. So let's just take a look at this method. And what they said was, if I just look at how it changes from A to M, that increases by 6. Then I know it increases by 6 from M to B, so I'm just going to add 6 to M, and that's going to give me 9. Then go over to the Y and do the same thing. How does it change from A to M? It goes up by 6. So how will it change from M to B? It will increase by 6. It will be the same. So that would be 10, and that's the same value that we got using the graph. There's an algebraic way. I think it's a little cumbersome, but if you're interested, I'll be happy to show you that one tomorrow in class. Here are a few practice problems that I would like you to do. We will work on the homework then tomorrow in class, so you can stop once you've finished problem 6. Thank you and have a good night.